Okay, so welcome to the last day of our preview daily practice. So in this practice, we are going to look more about the trigonometric functions. And after our practice today, most of you guys will be entering our summer classes. So in the summer, we will also break down into two kinds of activities we're going to do. It will be math competition focused, or it will be more school track like AP focused. So stay tuned to our new event in our WeChat group for more information. All right, so anyways, let's take a look on our practice set here. So given that the terminal side of the angle theta passes through the point 3 and -4, what's going to be the cosine value? So in this case, we can first find this point, right? So we know 3 and -4 is going to be in the fourth quadrant, like this. And then this will be 3 and this will be -4, and this will be our angle. So here, the cosine value is going to be the adjacent over the hypotenuse. So we are going to take the adjacent, which will be equal to 3. And then, because it's a 3, 4, 5 right triangle, we know the hypotenuse is equal to 5. So we have a 3 over 5. So the cosine theta is equal to a 3 over 5 for this angle. Okay. All right, so now let's take a look on the next one. So given the terminal side of the angle theta passes through the point P to A and A, where the A is larger than 0, then what's going to be determined from this from this one here? So first of all, we are not able to tell the sine value or the cosine value, because here the sine value and the cosine value given here are both positive answers, right? And then you have to take a look on the value of the A to see if you can find that. So in this case, we do have the A is larger than 0. So in this case, we can know that it's going to be a positive value, but you should be really careful with all the sign. Okay, and because we know that it's a positive value, we can also determine the hypotenuse. So we can first see that the hypotenuse is going to be the square root of 4a squared plus the a squared, which equals a multiplied by root 5. All right, so this will be our hypotenuse. So therefore, the sine value is going to be the y adjacent. So a over the a multiplied by root 5, and that's going to be a 5 over root 5. Okay, so this will be the sine value. And then for the cosine value, we are going to take the adjacent. So 2a over a multiplied by root 5, and in this case it should be a 10 over root 5, so not quite what we have here. And then the tangent value will just be the opposite over the adjacent, so it should be the a over 2a, which equals 1/2. And you can see here none of them will satisfy our requirements here, so we only have the answer choice A to be correct. Okay, so now let's take a look on the problem 3 here. So for the problem 3, given that the sine alpha is less than 0, then what's going to be the value? Where's going to be our angle alpha? So we know the sine value represents the y coordinates, right? So given the y coordinates is less than 0, you can only be below the x-axis. So there's two quadrants, and this should be quadrant 3 and quadrant 4. So this will be the answer choice D. Okay, and then for the problem 4 here, and also for the problem 5, we have two calculations. So for the problem 4, we're going to evaluate a sine value here. So to evaluate this sine value, first of all, if you are not sure about all the identities, what you can do is try to draw a graph and then see this by yourself. But we can also see that the sine 120 degrees is the same as the sine value of 180 degrees and minus a 60 degrees. And then from our just the trigonometric identity, we know that sine value of pi minus theta is the same as the sine value of the theta. So this will be the same as the sine value of 60 degrees, which equals root 3 over 2. All right, so this will be the answer choice B. And for the problem 5 here, we are told to evaluate this function here. So we have the cosine squared of 111 degrees and then plus a sine squared of 111 degrees. In this case, even though we are not able to evaluate these two cosine and sine functions by hand, however, we can apply the Pythagorean identity, and we know that the cosine square of the angle theta plus the sine square of the same angle theta is always equal to 1, according to the Pythagorean theorem. So we can see that it's going to be the answer choice B. Okay, so that will be all for the daily practice today, and good job on making all this practice, and I will see you guys next time in the summer.